upper density. So what is the idea behind it? I'm not considering all the infinite number of terms. I'm going to consider the number 1 and next number is 1 by 2. I'm not at all considering any values in between 1 and 1 by 2. If you consider this example, the first element in the sequence is basically 1. Next element is basically 1 by 2. What is the meaning of it? Instead of considering 1.999, 0.9 0.9997 like that, I'm considering 0.1. After that, the second parameter, I'm considering it to be 0.5. I'm not at all considering any values between 1 and 0.5. Now the question is nothing but what? Can we identify this triangle by means of only finite number of parameters? Yes, of course, we can identify by means of finite number of parameters. This has been proved theoretically by using this 4 decomposition theorem that we will discuss it. But this much of theory people cannot understand. So I just wanted to explain it in a. So hope you are able to see my video. I'm requesting the audience to see my video. I'm going to explain it in an analogous way, the 4 decomposition theory. Okay. So the idea is nothing but what you consider my hand as one fuzzy number A, another hand as fuzzy number B. Okay. Now, how my hand can be identified? By means of my fingers. How this hand can be identified? Again by means of fingers. So how am I going to compare these two hands? I'm going to check the fingers one by one. Let me check the first finger of capital A, first finger of capital B. If they are different, if the first finger of capital A is different from first finger of capital B, then I will conclude that A is different from B. Suppose if they are one and the same, what would I do? Okay, first parameter failed. I will go to second finger. I will check again the second finger of A as well as second finger of B. If second finger of A and second finger of B are different, I can stop the procedure. Suppose if they are same, what do I need to do? The enough information is not guaranteed, so I need to go for third finger. So this is how we are identifying. Now in the case of decomposition theorem, what is happening? Now assume this hand as fuzzy number, each finger is alpha cut. In the case of decomposition theorem, what is happening? The hand consists of infinite number of fingers. Okay. What is the fourth decomposition theorem refers? My hand consists of finite number of fingers. I can identify my hand by means of finite number of fingers. So this is what is happening. I think I have exceeded my time. I think 1 hour is over. So let me stop. So this is what the basic idea of comparing two trapezoidal fuzzy numbers. Let me end up my lecture because I think 1 hour is over now from the time which I have started. So this is what the idea. We are going to compare two fuzzy number by means of hands, by means of the fingers. The fingers are nothing but alpha cuts. Simple. Alpha cuts are closed interval, and we know how to compare to closed interval. That's it. So maybe in the some other time in the near future, we will meet in person. By that time, let me explain the concepts in a much better way by giving some real life examples also. Let me end up my lecture. Thank you. Thank you, Ananda. And if you guys have any question, especially the UGPG students, if you have any questions, please don't hesitate. You can ask your questions. Don't worry about your language. You can ask your questions in any language.
Good morning, everyone. Myself is Dr. Chandrasekhar. So today I'm going to deliver my topic on hydrodynamic stability of swirling flows, insights and applications. Am I audible to you, everyone? Hello? Yes, ma'am. Yeah, just I'll start with my topic. So in my topic, I'm going to cover the following points. So basic definitions, introduction to the my problem and governing equations, literature review, results, and validation with examples, graphs, applications, references. Okay. So few definitions I'm going to explain here. Before going to modelize the problem, let us know the basic definition. Then only we can go into the deep into the problem. So before explaining the definitions, let me show you one diagram here. Now what I'm going to take actually, what I'm going to derive the problem. Let us see first. Now we are taking the two concentric cylinders, concentric coaxial cylinders. Now we are going to observe the fluid inside between the two concentric cylinders with radius R1 and R2. Now the fluid is we can say some of the terms here. It is inviscid, incompressible, hydromagnetic swirling flow in between two concentric cylinders. Now we are going to observe this fluid, whether this is stable or unstable, if you give some disturbance to the fluid. Okay, so before going to the definitions and my topic, let me explain one application first, then I will come to the my talk. Okay, yeah. Now this is the heart blocks. You know heart blocks. When you go for the angiogram, they will inject one injection through veins. Correct. Now here, what we are going to consider here, this vein is we are considering like a outer cylinder, and whatever the thread injected inside, that we are considering like a inner cylinder. Now the fluid in between these two cylinders is our fluid. So now when you inject this thread injection, now see we can observe the fluid flow. Laminar means it will be there stationary along the veins. Now wherever the blocks are there, the disturbance will happen with the fluid. Okay, now we are going to find out where the fluid is stable, where is unstable, and can we reduce the instability region or not. That is my main concept, which I'm going to explain. I think you are trying to understand a little bit. So let us come to my topic now. Yes. Now let us cover the basic definitions first. Now I'm going from the beginning. Now you see first one, fluid mechanics. Now it is one of the branch of science which studies the behavior of the fluid of motions and stationary. If we are studying behavior of the fluid of motions, which is called fluid dynamics. If you are studying the behavior of the fluid at rest, it is called fluid static. Now there are some subdisciplines are there, aerodynamics and hydrodynamics. Aerodynamics deals the motion of the fluid, motion of air, and whereas hydrodynamics deals with the motion of the liquids. Now viscosity, these words we will use in my problem. So I'm going to explain this. What is the viscosity actually? Viscosity is something, what is it? It is the thickness of the fluid, or we can say it is a characteristic of the fluid, the physical property of the that characterize the resistance of the fluid flow. Okay, or different liquids or different fluids having different viscosities. Here I mentioned some of the fluids: syrup, honey, engine oil. These are the liquids which are having different viscosities. Now inviscid flow. What is inviscid flow? The flow which is where the viscosity is equal to zero. Do we have such type of fluids? Yes. Do we have? We have superfluids. Liquid helium-3 and helium-4 are we can say inviscid fluids where the viscosity is zero, and water and air are having a negligible viscosity. So we will consider these two are also inviscid flows. Now density. What is density? It is the mass per unit volume, and it is denoted by the letter rho, and rho equal to mass per unit volume, m by v. M is the mass and v is the unit volume. Why I'm explaining all these things? These terminologies we'll use in modeling my problem. Okay. Now pressure. Now it is defined as the force exerted per unit area. It is denoted by the letter P equal to F by A. F is the force and A is the area. Then let us come to the incompressible flow. The flow in which the density is constant within the fluid parcel. It is called incompressible flow. Means here In fluid, if the density is constant, we can say the fluids are incompressible. Now that is what we are going to consider incompressible fluids only. Okay. Now what is the opposite here? Compressible flow means the flow in which the density changes with the application of the force is called compressible flow. Here are the examples. All the liquids are incompressible, and all the gases are compressible flows. Okay. Now let us explain about two types of fluid flows. One is the laminar flow and one is the turbulent flow. Okay. What is laminar flow? Laminar means it is actually, we can say it is a regular order, you can say order flow. It is one of the type of order flow, and the turbulent means it is not order, means it is, we can say it is unordered flow. Okay. And how can you say in other words? Now it is a the flow travels smoothly and regular in path, or we can say the flow in which the layers are slide past and to another without getting mixed. It will not mix it together. Okay. We can say example, the flow of water in a tap, in a pipe, and the flow of water in a blood flow through veins. These are all the laminar flow examples. Let us come to the turbulent flow. We, as I said, it is not orderly flow, it is unorderly flow. Okay. So how the flow behaves? Now the motion of the fluid is violent and disorder where the energy gets dissipated. Okay. Now this flow will change according to the time, with the time. What are the examples here? The flow of water in turbines, flow of wind in a cyclone. Now in mathematical point of view, we can say uh, the flow in one direction is called laminar. The flow with different directions is called turbulent flow. A simple way. In mathematical notation, you can say like this. Now, transitional. What is transitional actually? Now, the flow alternate from the laminar, being laminar to the turbulent is called transitional. This period is called transitional. Now we can take example here. The smoke which comes from the cigar, it instantly goes in a one direction only. So this is laminar, and after some time it will split into different directions. So here from the laminar to the turbulent, the flow in between these two is called transitional. Okay. Now unstable. What is unstable? Unstable fluid. Now the transfer of energy uh, from basic flow into the disturbance, and the disturbance will grow. It will grow in magnitude. It is called unstable. It will not decrease. Okay. So what are the examples here? Sea waves and tsunami, we can take it as a unstable flows. Stable, the same thing. The transfer of energy start from disturbance, and now it will from disturbance to the basic flow, and the disturbance will be decay in time, are called stable flows. Okay. Now these disturbances are very small. We can neglect it also. We can say infinitesimal. Okay. So what are the examples here? Tap water with low pressure are called are examples of stable flows. Now steady and unsteady flows. Now see here, in a flow, if there is no change at a point, or with the time, then we can say the flow is called a steady flow. Oppositely, we can say unsteady. So the fluid properties will change at a point with the time. Now it is called unsteady flow. Okay, now we are going to deal with the hydrodynamic stability. Now let me explain about this hydrodynamic stability. Now it mainly concerns the stability and instability of the motion of the fluid, and it also studies the flow transition from the laminar to the turbulent. If the flow is unstable, then how these unstables cause the development of the turbulence. That's we'll study that is the background of hydrodynamic stability.